when we to solve a differential equation means that we express the dependent variable as an explicit form in terms of the independent variable, right? So the first thing that we need to do is to look at the differential equation and to figure out which of the two variables is dependent and which one is independent. Of course, usually y is dependent and x is independent, but it's just that to make a point. So notice that there is y prime here, right? So y prime means that y is differentiated. So, and whatever of them is differentiated with respect to the other is going to be the dependent variable. So which means that x is independent and y is dependent. Alright, so the next thing is to rewrite the differential equation using dy dx rather than y prime. So why is it so is going to be clear a minute later. So dy dx equals, I'm going to write it like this, x squared times 1 over y, because when I wrote it like this, and you notice that this is the product of two parts. The first of them is a function of x, and the second part is a function of just y, which means that the differential equation is separable, right? So, and if it is a separable differential equation, we need to separate the variables. So when we separate the variables, we treat dx and dy as if they were just numbers that we could multiply and divide, right? So we need to move everything with y, including dy, to the left hand side, and everything with x, including dx, to the right hand side. So which means that we need to multiply our equation by dx, right? So then dx on the left is going to cancel out and it's going to disappear, and we are going to multiply our differential equation with y, because then 1 over y times y on the right is going to cancel out. So, and then we are going to get y dy equals x squared dx. So now the variables have been separated. So the next step is to do integration. So then we integrate. Okay, so the integral of y dy is going to be y over 2, y squared over 2, equals the integral of x squared is going to be x cubed over 3 plus constant, right? So we shouldn't forget the constant. Okay, so then in order to solve for y, the first thing that we need to do is to multiply by 2, right? So then let's solve for y squared first. So y squared equals 2/3 x cubed plus 2 constants, right? So 2 times c. Well, but what is this plus c? So this is just any real number, right? So the c is any it represents any real number. But if c is an arbitrary real number, then 2c is also an arbitrary real number. There is no restriction. So if c can be anything, then so can 2c. So therefore, here, when we write that y squared equals 2/3 x cubed plus 2c is as good as writing that this is equals plus c, because either c or 2c, it just stands for any real number, right? So where c is any real number. So which means that we can just delete this multiplier too. Okay, and then finally we need to solve for y. So y equals, well, if this is y squared, then y itself should be plus minus square root of this, right? So 2/3 x cubed plus c. Is it done? Not yet, because notice that what we haven't, it is actually good to do it in the beginning, but I delayed it on purpose. That the right hand side of our differential equation has division by y, right? So which, and if y equals 0, then we couldn't divide by y. And so it means that the right hand side of our differential equation, its domain is not the entire plane xy, but rather it's the entire plane xy except for the line where y equals 0. Right? So in order to be able to divide by y cannot be equal to 0. So which means that it is actually good to include this restriction into the answer as well. So we should write that y shouldn't be equal to 0, and this is the final